the Pythagorean theorem today, and I want to emphasize on one important fact about the Pythagorean theorem, that it only works on a right triangle. That means a triangle that has one 90-degree angle in it. Okay, and if you notice here, we have only one longest side, and we always focus on this side as being what we call the hypotenuse. Hypotenuse, as you know, is your longest side, and the variable that we always use, mostly anyway, to represent the hypotenuse, letter C. Okay, so this side right here is letter C. The two other sides we call leg. Okay, the two shorter leg anyway, and we use letter A and B to represent it, and you can actually use them interchangeably for either leg. It's fine, but just go ahead and stick with C for the longest side, then we're all good. So according to that Pythagorean theorem, it's stated that if you take the square, the sum of the square of your two shorter legs, it will equals to the square of the longest leg, which is the hypotenuse. So it comes out to this: a squared plus b squared equal to c squared, and this is the basis of the Pythagorean theorem. And I encourage you to have this down, written down, write out every time you have to work on a problem, just to help you get started. Okay, so here's the first example that I want to show you. Pretend I have a equals 7, b equals to 13, and of course I do not know what my c is. And as we know, since I give you this format, ABC, C would be your hypotenuse, which is your longest side. Hypotenuse. Oh, I misspelled that. Okay, that's what I want you to find. So please always refer back to your Pythagorean theorem formula. A squared plus b squared equals c squared. And then plug in what you have. A is 7, so I'm going to plug that in. B is 13. Here's 13 squared. And of course, C is what we're trying to find, and simplify the best we can. 7 squared, 49. 13 squared, 169. And go to C squared. 49 plus 69 is 218. And if we want to solve for C, we have to get rid of this square. The way that we do it is always taking the opposite, which is the square root of it. Okay? If you take the square root both sides, you would have the square root of 218 on the other side. Notice that 218, take the square root of 218, is not going to be pretty, because 218 is not a perfect square number. However, we can actually make an estimate of this number. For example, the square root of 218, on the right hand side of it, the next perfect square number is going to be 225. And the left hand side, the next perfect square number is going to be 196. Well, we know the square root of 196 is 14. Square root of 225 is 15, so we know for sure it's 218 is in between 14 and 15, or in other words, it's about 14 point something. 218 is actually a bit closer to 225, so it's actually bigger, more than halfway. So definitely, you know, the answer is going to be above 14.5. But since it's actually closer to 225, we can actually estimate it to be about 14.7, 14.8. And it is close enough, and we just say, well, C is approximately 14.8. Okay, it's a good enough answers. So with that, I want you to go ahead and try number 11, page 30. Okay, all right, moving on to the second one. It's another variation to problem. Instead of giving you, in writing, I give you a figure like this, and I say, well, okay, what if I give you the side? It's a right triangle. I give you the longest leg as well. It's always the opposite of your 90-degree angle. I want you to find the missing side. So you can call this, if you call this A, then that's B, whatever you want. So let's say this is the B, is the missing side. I always start out with my Pythagorean theorem, okay, and then fill in what's missing, or what's available. So A is given, 12 square. B, I'm trying to find out. And C is 20, so that's going to be square. So 12 square is 144. 20 square is 400. Subtract 144 both sides. I have b squared equals to 256. Now if I take the square root of it, both sides, b is going to give you 16. So let me just kind of write it out. A is 12, b is 16, and c is 20. Notice that special case here. All three numbers are all whole numbers. No decimals are involved, right? When you have a case like this where all three sides are whole numbers, we call this Pythagorean triples. So we have a specific term for it. Okay, just to let you know that there's a specific term. Okay, and go ahead and try number 3. on page 30 as well. Why don't you try to figure out other Pythagorean triple if you can, and let me know about it when you get back to class. Okay. All right, let's take a look at the last one right here. This is called using the converse. Well, what does it mean? We'll talk about that in a minute. And let's pretend I have this for you. I have 9, 12, 16. This time I notice I gave you all three sides. So let's label A, B, C. Of course, my longest side is always the C. So supposedly, I'm trying to prove that these three sides, if I put together, will help me form a right triangle. Can that be done? Well, you can verify it by using the Pythagorean theorem. See if it's going to test out okay. That means if I take the two legs, square both, and add them, that should add up to the square of the longest side, which is the hypotenuse. Will that be true or not? If it's true, then the answer is yes. It can form a right triangle. If it's not true, then you just say no. It won't be able to, it will not form a right triangle at all. So let's plug it in and test. Here's 9 square. Here's 12 square. 16 square. 9 square is 81. 12 square is 144. 16, 256. 81 plus 144, as you know, is 225. It's obviously quite clear that 225 is not equal to 256. Therefore, the answer is no. If they're equal, then you say, well, it can form a right triangle. If the answer is no, it cannot form a right triangle. Okay, so try that out and work on this problem for me on page 30. We'll discuss this when you get back to class. That's it.